very cool to see a full audience looking to learn something about turning data into vectors. I'll just start by 2 sentences about myself. I have been building machine learning infrastructure at YouTube for about 7 years. And then I left the company in the end of 2018. And since then, we have been experimenting with representation learning and information retrieval. And I want to share today with you a few learnings from that experimentation. And just to make you come to the talk, we had to go a bit controversial on the talk title. So yeah, the idea is that all the data practitioners by this time next year should have some idea of what does it mean to turn data into vector embeddings. All right, let's dive right in. So what is going on with all this stuff? You might have been hearing about vectors. There is now 15 different vector databases. They have raised a lot of money. Even all the mainstream media now talks about the ways to add memory to large language models through basically information retrieval. Even mainstream media now talks about retrieval augmented generation, which it seems totally crazy to me. And then the developer attention in building machine learning systems seems to be unprecedented. The top projects on GitHub together maybe have more than 1 million stars. All kinds of frameworks to help build smart systems, basically. So there is a lot of attention from all the different sides, a lot of money. So what is going on with this hype? I hope I can untangle some of this today a little bit. And just aside, a lot of this stuff, I've seen folks from Microsoft and different big companies. This stuff is not super new, So if you just think about the 10% of Google.com searches being vector powered already in 2020, and 10% of Google searches is a lot. So this is somewhat, these ideas are somewhat mainstream already, but I think there is still a lot of confusion and people don't quite understand the whole landscape. But the big guys have been doing this for a while, and vector embeddings drive a lot of the experiences that you encounter, from ordering a car on Uber to listening to your next song on Spotify and consuming content, and all of this is vector powered nowadays. So it must work, right? So that's kind of the basic idea. Okay, so let's just kind of look at one example of large language model powered workflow, and then from there we will try to unpack how these vectors come into the picture and look at other use cases as well, right? So I try to make this as practical as possible. So the basic kind of use case that you see for language models, right, is answering questions. It can be support or search-like experiences. And so, for example, we could be getting a question, something like, why should a young couple buy a hatchback on a car website, right? And we want the system to come back with some sort of answer that makes sense, right? So here is like the reasons you should do it. And by the way, here are 4 cars we have in stock that you should buy. This is some sort of automated experience that we are looking for, that's supported by language models. But then somehow the model needs to also know which cars we have in stock, right? So there is some information that's not trained into the model, and this information makes the answer actually useful if you want to, for example, sell more cars. So this is like a very basic example of what we might be doing that's enabled by vector embeddings. So let's talk about how you would build a system that does this. Because you might be building one soon, if you aren't already. So just a very basic software stack, right? You have some front end where the user comes in with the question. Then you have some sort of backend, some sort of language model here that takes that question and turns it into a vector embedding, which you should just think about as a point, like a coordinate point in a space that helps you understand what the question is about roughly, right? You know that similar points will talk about similar things. And so you use the model, you get the point, you have a vector database, assuming you manage to choose one of the 15 ones on the market. And you have previously, loaded your cars into the database, and so you take the vectorized question, you find cars that are nearby, which means that their vectors are somehow related to the question, so they are relevant. For example, they might be hatchbacks, right? Because the question asked about the hatchback. You then fetch those cars out of the database together with their metadata, and you use a language model again to say, okay, please, here is a question from the user that I need answered, and here are 4 cars that we have in our database that we might want to sell. Please compile this into an answer for the user, right? So this is the basic anatomy, right? Here we have a pre-trained language model. We have not trained this. This is from OpenAI or one of the open source models. And we are trying to inject into this process some data that we have in our company. This might be customer data, it might be product data, whatever it is that's specific to your use case. We are, through this mechanism, injecting it back into the process so that the answer actually means something in the context for the user and gets them to the next step or gets them to solve their problem. This is how we make the stuff useful. The data engineers in the room, they think about the pipelines. So when I show you something like this, okay, cars in a vector database, you think, okay, how do I get them in there, right? So there is probably some ingestion happening, right? So you might have your car database with your metadata. And again, you need to turn that car into a vector as well, so that when you vectorize the query and when you vectorize the car, it kind of meets in the database, and the database then helps you find the vectors that are close to each other, right? And so there will be some sort of data pipeline that you need to build, right? And now we kind of have the model used in 3 different places in our stack, right? We have something that turns data into vectors in our ingestion. We have something here that vectorizes the query, and then we have something here, possibly the same model, that actually answers the question, right? And so this stuff is what you have to figure out, where to take it from, how to run it, how to deploy it, how to maybe coordinate the releases of new models across those different places. But this is more or less the picture. If you want to build a demo, right? So, as all of you know, to kind of get the new project out of the gate, you want to have some sort of proof of concept that shows the initial value, and this is roughly the anatomy of your proof of concept, the most basic way that you can do this, right? And then maybe you can A/B test it with your traditional search interface, right? You had the car search before, where I can type hatchback and then some hatchbacks appear, right? We have had this for decades. You can A/B test a question answering interface next to it and see, are we selling more cars, or can we tune it so that we are selling more cars, for example, or answering more support tickets, or whatever it might be, right? So this is the basic stack. Now, you might be sort of asking yourself, why do we have to go through the trouble of having this additional piece here? Why are we not training the car data into the model itself, right? Because then we could just ask the model, hey, which cars are available today, and we would have the metadata trained into the model, and then you don't have to do all this other stuff here, right? So somehow this maybe is a question in the back of your mind, and the process of kind of taking a language model and adding information to it, one of the buzzwords that you can Google that people use is fine-tuning, right? We are kind of adding information into a pre-trained model. And the approach that we have shown with the vector database, the buzzword for that one is retrieval augmented generation, and they both have a place, right? When you are thinking about fine-tuning, it's quite useful if you want to force the model to answer only in certain language, right? Or only in certain output format, or only make it sound like a drunk pirate. Fine-tuning is a way to kind of really emphasize that and train that into the model. But it's really bad if you want to bring in information about the new car that just came into your stock, right? Because it's really expensive to do, right? And so in those cases where we have facts that we want to add to our stack, we use the vector database flow that we have shown. It's cheaper, faster, and you can do access control. So for those of you in the enterprise, to answer the question, certain users might only have access to certain facts, right? And you would want to have that kind of access control in your retrieval, as opposed to somehow trying to make different models for different user groups. That doesn't work. So there is place for both of these, fine-tuning the model and retrieving facts to help the model answer a question. And you have to, combine, the best systems combine a bit of both. Well, and then, so you have done your proof of concept, right? The manager liked it, you got more budget for it, and, it A/B tested reasonably well. So it's time to actually launch this thing, right? It's time to bring this to 1 million users and actually move, actually grow the bottom line of the company and get promoted and all that good stuff. And that's the point where a little bit more concerns come up, right? For example, you'll realize that this very simple ingestion through one language model where you took all your car metadata, turned them into one big flat string, and then calculated the vector for it. Actually, you lost a bunch of information in there, right? Because you have categories, you have numerical parameters, right? And if you sort of embed that as a part of one big string, it's completely unpredictable, right? You don't have any fine-grained control over it. And so you start to think, okay, what are my actually different sources of signal for the problem of surfacing the right car, right? I might have user behavioral information. I might know that the user clicked on certain cars before, right? So I probably want to bring that into the process. I might have user feedback. People are maybe explicitly giving me thumbs up, thumbs down for different suggestions. I might have a car availability database that's separate from the just which cars exist, right? And so I might have to balance the availability with relevance for the query. And then maybe, I have a kind of curated resource that talks about cars in that kind of language that you use to talk about cars. And maybe you want to create a data set like that to fine-tune the model so that the answers are a bit more professional or a bit more like the user expects. And then, you need to wrap this in some sort of data infrastructure so that when a new click or a new car comes in, you are updating your vector database, right? So this has to be, probably some Spark jobs will be involved here. Maybe some Kafka stream processing will be involved. And you have to figure out how to build this thing, So that's the job for 2024. And then, obviously you have your different web interfaces and apps where a lot of this stuff will surface. And so if you kind of squint and look at this from the distance, it's starting to look like a pretty standard information retrieval task, right? Like this kind of similar thing you would do for all kinds of other use cases, right? And so we kind of shouldn't be surprised. The thing is that information retrieval, it's kind of it underlies a lot of the different problems that we have in our kind of machine learning stack, right? You want to usually get some sort of candidates, candidate transactions, candidate products, or some sort of context, right? You want to retrieve this, and then you want to run some model over it to predict the next click, or to score it for a recommender system, or to score it for fraud. So that first step of retrieval is always there. And, if you are just working in one of the verticals, one of the use cases, I think people tend to just sort of have a little bit of blinders on. And the point I'm trying to make here is that actually all the information retrieval people across the company should be working together because they are ultimately solving the same problem. Okay, so let's run through a few of these different applications. We talked about this one, retrieval augmented generation, right? So just to summarize, in this problem, your vector computer, this model and infra box in the middle might be consuming your knowledge base and your accepted answers and your analytics with user behavior, might be combining it together. Vectorizing and updating your vector database, right? This would be some sort of Q&A system on top of a knowledge base. So this might be one of the things you build next year. In cybersecurity, it's quite useful to understand how different access patterns relate to each other, right? Different user accounts behave similarly. So again, kind of similar picture. You might be consuming user metadata, a threat database, stream of network traffic, and calculating vectors for your users for the different transactions going on in the system, so that when one of them is flagged by a human, let's say it's fraudulent, you can very quickly see which ones look similar in your vector database, and then kind of take that label from the known example and apply it to the similar users, similar transactions in the system, right? So could be quite useful for this use case as well. Obviously, recommender systems. So if you work in any kind of web company that's trying to put the right stuff in front of your users, then this is one of the problems you are dealing with on a daily basis. And again, you might be combining your product database, your purchase data, your user analytics, and a bunch of other sources of signal to calculate your product vectors, your user vectors. So when the user actually logs into your website, you can find the products that have a similar vector and show it to the user so that they hopefully buy it. And you kind of see the pattern, right? There is some data sources on one side. There is the compute problem in the middle. How are we turning this data into vector embeddings? And then there is some place where those vectors go, and it's either storage, right? Because you are kind of creating a vector data set, training another model on it, or it's a vector database that helps you at, in the real time figure out which vectors are similar so that you can handle the use case for the end user. Another example in fraud, where you would be identifying fraudulent merchants, like sellers or buyers, based on, again, combining all those different signals. Personalized search, right? So personalized search and recommender systems is kind of the same thing, except a search interface also has a user query, right? But they both have some context of what the user wanted before, and you are, again, blending all of this together and making those vectors, right? Ad selection, same problem, right? So hopefully, like going through those examples made it clear that a lot of the problems that we are kind of solving in data and in machine learning have this sort of structure, and knowing techniques of how to choose the right models for the different data sources and how to combine them together. That's that's a good idea to know. So here's a quick summary. It is kind of like a study plan, right? Quick summary of what might be the different things you are thinking about when you are building this box in the middle. I'll just run through that very quickly. Actually, what's my time? Cool. Yeah, so I'll run through this quickly. We were talking about all kinds of different data sources, and some of them are text, a description of a product. Some of it is structured, where it might be sort of history of interactions between users and products, right? So these are the examples of structured and unstructured data that you might be wanting to convert to vectors. This data might be coming one click by click, right? Where, let's say you want to personalize in the real time, like TikTok, so you need to be somehow consuming a data stream. But it also might be a database of all the cars that you want to vectorize, right? And so you should probably have both of those kind of data velocities covered in your vector computer. And then finally, this is kind of the new stuff, right? So it used to be the case that every serious company did only custom models, right? You figure out what's the data. You have a 6 to 9 month project. You figure out where the signal is coming from. You construct and train your model and go from there. This is now kind of the last couple of years. We have more and more pre-trained models available, open source, commercial. And so what you have to figure out as a kind of data platform engineer at your company is how are you combining those two types of models? How are you bringing in the pre-trained stuff? How are you enabling your data scientists to train custom models? And then how is this coming together? Because at the end of the day, the product vector needs to somehow reflect both, right? Or the user vector or what have you. So you need some strategy for how these things converge at some point. So yeah, I think this is, you all took a picture of this. That was the right slide to take a picture of. Cool. And actually I want to take questions now. So I I have been running around this event and talking about this stuff with folks, and there is a range of attendees at this event, from data scientists who have been running vector embedding models and training them for years, all the way to, let's say, data practitioners that are just learning about the topic. So I want to, make sure that if somebody has a question, that I at least know about it. We are launching educational resource, so that's where the QR code goes to. We call it Vector Hub. We have a lot of external contributors, super practical examples. I'm an engineer, so that's the type of stuff that I like to read. This is launching in a week or two. And then unsurprisingly, we have a computational framework that helps making these vector computers, right? So it's an easy way to declare what you want in your vectors and where this data is coming from. And then from this, we basically generate Spark jobs or stream processing, basically executors that help you both play with this in a Python notebook, but then also launch using the same spec in production. And we are super early, we are kind of we closed some financing, and we are trying to figure this out, working with design partners. So, there is a way to ask for early access there. I think there is somebody that has a mic, yes. So if anybody has a question about turning data into vectors, we have about 8 more minutes, and I would love to hear from you.
Hey, thank you for the amazing session. A question on a use case of...
Okay, wait, sorry. Yeah, this helps.
So thank you for a useful session. A question on a use case of recommendation where you talked about how vectors could be utilized. We've worked on a similar problem, but we've used typical models like collaborative filtering where we did not have any unstructured data for our customers. So in such scenarios, by just using structured data, would you still recommend using vectors approach, and what will be the advantages of such an approach?
Yes, so short answer, yes. When you look at this picture, right, we have the analytics, right? So this is the graph data, basically, which users interact with which products, right? And the idea is that you ingest this type of signal and you run it through, let's say, a graph embedding model, right? And this gives you, let's say, a 400-dimensional vector that represents, this kind of product-to-user relationship. But usually, or hopefully, you have also other sources of signal. You might have some product descriptions, or maybe the users sign up and they give you a little bit of information about themselves, and that's where you might have some text, and you can run that through a text embedding model, sentence bird, E5, what have you, and that also gives you some dimensions, right? And the idea is that the system gets more and more powerful as you add more and more signal to it. So the mindset is, okay, let's identify all the data sources. Let's find the right models that turn those specific data points into embeddings, and then combine those embeddings together to have the ultimate user or product vector. And some of those sources will have missing information some of the time, but that's the idea. When you combine all of this together, it kind of gets more robust and more powerful over time. Make sense? Cool. Any more questions? Have anybody tried doing this stuff before? Was there something that didn't work? Or maybe it just worked super well? I have one more slide if nobody asks a question, where I'll tell you that we have a booth, and this goes to my LinkedIn, and I post about this stuff sort of every 2 days, so that might be another QR code to scan. And I think we have a question. Yeah.
Yes. One question for me is, since those vectors are changing so rapidly, so OpenAI model, I think one of them just got changed very recently. Mm-hmm. How will you do when there is an update to a new embedding model?
Mm-hmm. So a couple concerns there, right? So one thing is, how do you make sure that you use the same model here, here, and here, right? So somehow you need a way to coordinate the rollout and understand, okay, there is a new model coming out. Hopefully the API helps you kind of by versioning in the API call so that you can switch to the next version at the same time everywhere, right? So that's kind of one concern. The other concern is if every time you have a new model, you have to re-embed, 10 million cars, that can be expensive, right? And so you need some sort of plan with dealing with that, right? You might, for example, only recalculate the part of the vectors. You might be, having a hot set of cars that you are using that handles sort of for most of the queries, right? And only there you keep the absolutely latest model, and then you have like long tail of products or cars where you don't care as much about the last 5% of performance on the model side. So you need some plan there. Otherwise, it gets expensive, and or the updates are super slow, right? And that also you don't want. If there is a new car coming in, you want to get the vector for it as fast as possible. Yeah. And easy way to start with this is just I wouldn't be afraid of the OpenAI APIs, right? For a couple $100, you can embed tens of thousands of documents. You can handle queries sort of reasonably fast. It's not going to be the best system. It's not going to give you a lot of control. But I think one of the failure modes in the industry is that you immediately start to think, okay, we need the best possible model. We have to host it ourselves. We need to fine-tune it before we even start. That's also not the right approach, right? So I think because of the pre-trained models nowadays, it's super easy to just make demos and pilots, and you should take advantage of this to get the execs in your company excited. But then very quickly think about, okay, how to professionalize this deployment. How can we have typed interfaces end-to-end? How do we, treat this like engineers? Because that's the other thing that we see in the industry is there is a lot of demos, a lot of hype, but then getting stuff to production because people don't put the engineering hat on basically doesn't happen or takes super long, or people launch stuff that just blows up, right? Because 20% of the answers don't make sense. And then your users lose confidence in the system, right? They have heard about AI revolution, they come to your car website, and it doesn't work that well, right? So that's when the control and kind of micromanaging the data sources, choosing the right models, and having the user feedback is super important. Cool. So if there are no more questions, I think we can wrap up. Thanks a lot for listening. And see you on LinkedIn.